This is a common word problem in quadratics. You have a company and its cost C is given in terms of X units of product. So this is the quadratic equation that models that. And what you want to do is you want to find how many units of product minimize the cost to the company. So I need to find X that minimizes the cost. And minimizes is an incredibly useful and important word here. Minimizes points to a very specific point on my parabola. So for a parabola, the lowest or highest point is always the vertex. Okay, so I am trying to find the vertex, and in this case, because it says units, and units is x, I have to find the x coordinate of the vertex. That's my goal. Let's do that. So I can do this in two ways. One way is I can complete the square on this function. I'll do that now, and I'll show you the second way. So the first way is to rewrite the equation, partially anyway. So I write it up to this x part, and then what I do is I add and subtract the same term, the same number. And this number is b divided by 2 all squared. So I half this number of negative 20, which is negative 10, and then I square that. That's 100. So I add 100 and subtract 100 from this equation. I keep that plus 300 around, okay? So now this part right here is a perfect square trinomial. It can be factored as x minus 10 all squared, and this latter half is actually plus 200. Luckily, the only thing I really care about here is this x value that pops up. So this is actually my answer. It takes 10 units to minimize the product because x equals 10 is the axis of symmetry. It's also the x coordinate of the vertex. Now, there's another way to solve for this problem using a formula. I didn't want to show you this way initially, but I'll show you it now. So I can also get that x equals 10 using this formula. X equals negative b over 2a, because this is the equation of the axis of symmetry in terms of standard form coefficients. So now b is negative 20, so negative b is positive 20 divided by 2a, which is 2, and I get 20 divided by 2, which is 10. So that's another way of doing it. Either way, again, the whole point of this problem is to find the vertex, and in this case, the x coordinate of the vertex. Let's say this problem didn't just say how many units of product minimizes the cost, they also wanted to know the minimum cost. That answer would be 200, because I can read it from my vertex equation.